Pure Mathematics, February, March 2026, paper 1-2. Question number 1. The equation of a curve is given by y equals x cubed minus 3x squared plus 9. Find the coordinates of the stationary points of the curve and determine their nature. So, since it is called stationary point or the turning point, right, we are going to find the first derivative of this curve. Remember, to find the stationary point, first we take the first derivative equal to 0 to find what we call the critical values. So whatever values you find after equating the first derivative to 0 are called critical values. And then to determine the nature, we find the second derivative and then substitute the critical values into the second derivative. If the answer is negative, that's less than 0, right, then the curve attains maximum at that critical value. If the answer is greater than 0 or positive, then the curve attains minimum at that critical value. So that's basically what we're going to do over here. So first, let's find the first derivative. dy dx is equal to, so you drop the exponents 3x and then subtract 1 from the exponent, so 3x squared minus same to the next term 6x and then plus 0. Then you're going to equate that to 0. Alright, so we get a quadratic which you can decide to divide through by 3, or you can go straight ahead and factorize it. That's also accepted. So we have x squared minus 2x is equal to 0. Now, since there's no constant term, you can factor out x, and then x out of this we have x here, and minus 2 is equal to 0. Then by the 0 multiplication theorem, x is equal to 0, or x minus 2 is equal to 0, which means x is equal to 2. So these are the critical values, x equals 0 or x equals 2. Then what we need to do is to find the second derivative, and when we are done, we substitute the values that we found, the critical values. So the second derivative, we differentiate the first derivative. The squared y over dx squared is equal to same method, drop the exponents and subtract 1 from the exponents, 6x minus 6. Then we do that, find the value of the second derivative at x equal to 0. What's the critical value? 6 times 0 minus 6 is equal to negative 6. This is less than 0. It implies that the curve is at maximum, right, at where x is equal to 0. Now next is you do the same thing, the squared y dx squared, substitute x equal to 2. So we have 6 times 2 minus 6, that is 12 minus 6, and that is 6. It is positive or greater than 0, which means the curve is at minimum at the critical value x equal to 2. And over here, what I need you to understand is that the negative 6 and the positive 6 are not the maximum and the minimum, respectively. All right, they are values that are helping us to determine what happens at these critical values. So you don't have to, you're not supposed to write the negative 6 and then positive 6 together with the critical values as your final values for the maximum or minimum point. So now that we know the critical values, the turning point, the x values are the turning point, and then whether they are minimum or maximum at those points, we need to find the corresponding y values. For our curve is y, let me write a curve here, y is equal to x cubed minus 3x squared plus 9. So we find y when x is equal to 0 and when x is equal to 2. So for x equal to 0, y will be equal to 0 minus 0 plus 9, and that is equal to 9. For y, x is equal to 2, y is equal to 2 cubed minus 3 times 2 squared plus 9, and that gives us 5, right? So it means you have 2 points here. The first point is 0, 9, and then the next point is 2, 5. And we've already said that at x equal to 0, the curve attains maximum, and at x equal to 2, the curve attains minimum. So we just have to stage them over here. So the curve is at maximum. So this is a maximum point on the curve, and this is a minimum point on the curve for question 1. And for question number 2, the diagram shows a triangle ABC with AB equals 12 centimeters, AC is 9, and angle CAB is 0.18 radians. An arc with center A and radius 9 centimeters is drawn inside the triangle as shown. The shaded region is bounded by this arc, the line segment BC, and then the and part of the line segment AB. Right? You have to find the perimeter of the shaded region, and our answer be given correct with 3 significant figures. Remember, perimeter is the length around a figure, right? So perimeter of the shaded region means that we need to find from, let me name this part D for identification purposes. So we need to find DB, line DB, line BC, and then arc CD. Then we know from A to B, the question says 12 centimeters, and the radius of this sector ACD is 9. It means that AD is 9, so this part is 3 centimeters, right? And then AD is 9, right? And then next is to find, let's try and find the arc CD, right? So we need to find length of an arc, length of arc CD. So length of an arc is r theta, that is the radius times the angle in question. So our radius is 9, and then times our theta is 0.8, and that gives us 7.2 centimeters. So we found this part to be 7.2. Now next is to find the length of the line segment BC. We have two sides given and then the angle between them. So we can use the cosine rule. So by the cosine rule, BC squared is equal to AC squared, which is 9 centimeters. So 9 squared plus AB squared, which is AD squared. No, AB rather, since we are finding the length of BC. So AB, what is 12 centimeters of 12 squared, minus 2 times 9 times 12, and then cos of the angle between them 0.8. So I'm going to point this on the calculator and give the final answer. And then make sure your calculator is in radians, right? The angle mode is in radians since the angle is given in radians. Or if you're working in degrees and you want to convert the radians to degrees by multiplying the 0.8 by 180, that's also fine. But then it's better you work in radians. So we find this, and then we get BC squared is equal to 74.511. Now we take the square root of both sides. So BC is equal to the square root of 74.511, and that gives us 8.63. But since we are going to write our final answer in 3 significant figures, 2 significant figures is enough. We found BC to be 8.6. Now we have all it takes to find the perimeter because every side has been found. So we just need to add all of them. So perimeter of shaded region is equal to our 8.6 plus the 3 and then plus 7.2, and that gives us 18.8 centimeters. That's the length of the perimeter of the shaded region as in this question. Now for question 2b, it says find the area of the shaded region and give your answer correct with three significant figures. I needed to display it over here as well. So the shaded region is between the sector and then sector ACD and triangle ABC. So you're going to find the area by first of all finding the area of the bigger triangle ABC, and then we subtract the area of the sector ACD from that, and then that will give us the area of the shaded region. So first, let's find area of the sector. Area of sector, and remember that is half r squared theta. So half our radius is 9, so 9 squared times our theta, which is 0.8. So we solve this and we get 32.4 centimeters squared for the area of the sector ACD. Now area of a triangle ABC, or triangle ABC. So we are going to use the formula half AB sine theta, where A and B are just two sides of the triangle and theta is the angle between the two sides, right? Remember, A and B are any two sides of the triangle, and theta is the angle in between the two sides. What that means is that if we are picking out A and B to be line AC and line AB, alright, then our angle is supposed to be 0.8. If we are picking line AC and then line BC, if you are picking line AC and line BC, then our angle is supposed to be the angle at C, which we would have to calculate before we do substitution. If you are picking line AB and line BC, then our angle is supposed to be the angle at B. That's supposed to be our angle. So remember all the time, the formula for the area of a triangle has to do with two sides, any two sides, times sine of the angle between the two. So since we have an angle over here already, let's use line AC and then line AB, which is 9 and 12 centimeters. So this is equal to half times our A is 9 centimeters and our B is 12 centimeters times sine of 0.8. Once again, make sure your calculator is in radians since the angle was measured in radians. Then we get 38.737 centimeters squared. Now for the area of the shaded region, we have area of the triangle. So let me write area of shaded region. Of shaded region is area of the triangle, which is 38.737 minus area of the sector, which had 32.4, and our final answer is 6.34, because we have to leave it to three significant figures, and that's the answer.
The question number 3. The graph of y equals ax squared plus bx plus c has its vertex. So the vertex is the turning point, right? at 3, -5, and then intersect the y-axis, which is also the y-intercept. Okay. At 0, 31. A. Find the values of the constants A, B, and C. So um, 2 points have been given, 3, -5, and then 0, 31. Right? The fact that one is a vertex and the other one is an intercept means that each of the 2 points satisfies the equation of the curve. So what we're going to do is that we're going to substitute each one of them into the equation. And then you can see from the second one, 0, 31, right? When x is 0, y is 31, and that is the y-intercept. And from this equation, y equals ax squared plus bx plus c. C is called the y-intercept. So we see that the value of c is 31. In other words, what we're going to do is that we're going to replace x by 0 and then y by 31 and then find out what c is going to be. So you can just try to do that. So x is 0, y is 31. So we're going to have 31 is equal to, of course, 0 squared is 0 times a is 0. So the first part goes to 0, second part goes to 0, and then we have c. So it means that c is equal to 31. So we can easily find the value of c from here. And then next is to find the values of a and then b. Right? And then we have this formula. The turning point of a quadratic equation is given by negative b over 2a for the x coordinate, and then the y coordinate is 4ac minus b squared all over 4a. So from what we've been given, 3, -5 means that negative b over 2a is equal to 3. So we're going to do that and then try and get one equation. So negative b over 2a is equal to 3. You try and rewrite it by clearing the fraction. So we have negative b is equal to 6a. In other words, b is equal to negative 6a. We can name this as our first equation, or equation 1. And then the next part, 4ac minus b squared over 4a is equal to -5, since that's the turning point. Remember, this formula is the vertex of every quadratic curve, or the turning point of every quadratic equation. So since the point has been given already, it means the y components, right? The y coordinate is equal to -5. It means that 4ac minus b squared over 4a is equal to -5. We found what c is, and then we've also found b to be -6a. So we can just do substitution into the formula, and then we find it. So we're going to have, let's do substitution. So I will maintain c for now, and then I will replace, sorry, minus b by -6a all squared all over 4a. Then we proceed and we have, so we have 4ac and minus 36a squared divided by 4a, and this should be equal to -5. I think you can factor out 4a from the numerator and then the denominator. So from the numerator, we factor out 4a, and then we have c minus 9a at the numerator divided by 4a is equal to -5. Right? Then the 4a and 4a cancel out, so that we have c minus 9a is equal to -5. Meanwhile, we found c to be 31, so I'm going to replace c by 31. So I'm sending the 9a to the other side and then -5 to where c is. But I'm going to replace c by 31. So 31 and -5 comes here. We have 5 equal to Negative 9a goes to the other side and becomes positive 9a. So we have 36 is equal to 9a. Divide both sides by 9, here by 9. And then we have a is equal to 4. Now that we found a, we can easily find b because from equation 1, b is equal to negative 6a. So it means that our b is equal to negative 6 times 4, which is negative 24. So yeah, we found the values of a, b, and c. If you like, you can just rewrite the equation and then substitute the values of a, b, and c. So yeah, our y is equal to, that one is not needed, but you can still write this anyways. Y is equal to 4x squared plus bx, but b is negative 24, so minus 24x, and then plus c. Our c, we found it to be 31, so plus 31, and that is a quadratic equation in question over here. However, there is yet another way you can go about this same problem, right? If you want to go by the differentiation approach. I remember the vectors or the turning points of a curve is found by finding the first derivative and then equating to zero to find the critical values, right? So we are going to use that approach to find the values of A, B, and then C as well. But then straight ahead, we know the y-intercept, which is the same as C, is equal to 31. So we can start from here that C is equal to 31 without any stress. Now next is to find the vertex of that equation. So we are going to find dy dx. Dy dx is equal to 2ax plus b. And remember, whenever you want to find the x value at the vertex, we equate the derivative to zero, right? And what this question is saying is that after equating the first derivative to zero, the x value that was found was 3, right? So it means we are going to replace x over here by 3. We are going to get one equation, which is going to help us solve the value of a and b. So, but then x is equal to 3. It means that our equation is going to be 2a times 3 plus b is equal to 0. Then we have 6a plus b is equal to 0, which is the same as the equation we had previously. This means that b is equal to negative 6a as our first equation. So that is the first approach. And then we can also go about the second approach. We can go about the second approach by finding this approach by finding another equation together with this so that we can solve the two simultaneous equations. Then the other approach is that, or the other method is that because this is a vertex, it means that the curve passes through the point 3, negative 5. So you're going to replace x by 3 and then y by negative 5. You're going to get one other equation, and of course c also by 31. So we x is equal to 3 and then y is negative 5. So negative 5 is equal to a times x squared. So x is 3. Then plus b times x, which is 3, plus 31. Right? Then we get sending the 31 to the other side. So I have negative 5 minus 31 is equal to 9a plus 3b. Over here we have negative 36. Let me write it over here. 9a plus 3b is equal to negative 36. I'm going to divide through by 3 so that I reduce the coefficient to simpler or smaller numbers. So we have another equation. We have the first one becomes 3a and the second one becomes plus b is equal to negative 12. But then, so this is equation 2. But then we've already said b from equation 1 that b is equal to negative 6a. So So we substitute that into equation 2. So wherever we see b, we replace it by negative 6a. So we have 3a minus 6a is equal to negative 12. We have negative 3a is equal to negative 12. Divide both sides by negative 3, here by negative 3, and it implies that our a is equal to 4 as we find previously. And then our b from equation 1 is negative 6 times positive 4 for a. That gives us negative 24. So all values have been found. Now you can rewrite our equation y is equal to ax squared. Now a is equal to 4. So 4x squared minus 24x and plus 31 is our equation. Now question 3b, the graph is translated by the vector negative 2, 7. Find the equation of the translated graph. So we already have the graph that we're talking about. So that's the previous graph we have over here. So, but then first of all, let's talk about translation of functions. So if I have a function f of x, sorry, and then the function is so my function is f of x and was translated by the vector ab. This is our translation vector. Then the new curve becomes, or the translated function becomes f of x minus a plus b. So it means that wherever we see x in the function, we replace it by x minus a, giving the value of a over here. And then after that, we add b, whatever value b is, to the entire function after everything. So it means that compared to the translation vector negative 2, 7, it means our a is equal to negative 2. Our a is negative 2 and our b is 7. So we pick the function and then try to do the transformation. Y is equal to 4x squared. So wherever I see x, I replace by x minus a. So it's going to be x minus, but a is already negative, so it's going to be minus a, and that has to be plus 2 squared. So we are squaring it because the function or the original curve has 4x squared. And we are saying wherever we see x, we replace it by x plus 2. And then there was already a square here. Then minus 24x, x again, so it becomes x plus 2. Then finally plus 31. But then we also need to add our b, and our b in this case is 7. So we try and simplify this expression or equation. So we have 4 here. We expand this fully. We have x squared plus 4x plus 4. Negative 24x minus 48, and 31 plus 7 is 38. Then we move on. We have expand the brackets. 4x squared plus 16x plus 16 minus 24x. Then negative 48 plus 38 will give us negative 10. So finally we have y is equal to 4x squared. 16x minus 24x is negative 8x. And then 16 minus 10 is positive 6. And that is our transformed graph.
Now we move to question number 4, which says that the function f is defined by f of x equal to this 2x plus 1 over x minus 3. And for the domain of x less than 3 means that the function doesn't take any values of x uh, more than or equal to 3. Right? You have to find an expression for f inverse. First of all, you let y equals f of x, which is the same as 2x plus 1 all over x minus 3. And then at this point, you can decide to make x the subject and And when you finish, you interchange x and y, or you interchange x and y, and then you make y the subject. So I'm going to change them first. So x is equal to 2y plus 1 over y minus 3. Then we make y the subject. We clear the fractions. So cross multiplication, x y minus 3 is equal to 2y plus 1. Then we expand this xy minus 3x is equal to 2y plus 1. Because we are trying to make y the subject, we all y terms to one side and non-y terms to the other side. So all y terms come to the right. So we have xy minus 2y is equal to 3x plus 1. We factor out y since it is common to both sides. X minus 2 is equal to 3x plus 1. Make y the subject, we divide through by x minus 2 over here and x minus 2 over here. So that's our y is equal to 3x plus 1 over x minus 2. And that's our inverse, we write. Therefore, f inverse of x, or the inverse of the function, f of x is equal to 3x plus 1 divided by x minus 2.
Question 4b. Given that f of x, so f composed of f is equivalent to px plus q all over r plus sx. You have to find the possible values of the integers p, q, r, and s. Remember, so you're going to substitute f into itself. Remember, f was given us. Let me write the f of x here. Was given us from the question 2x plus 1 over x minus 3. You're going to find f of x. So you're just rewriting f of x, but then wherever we see x, we repeat the entire f of x in place of x. So we have 2 here, and then because it is 2x here, we're going to replace the entire of x by 2x plus 1 over x minus 3. Then we have plus 1, all divided by x minus 3. So here again we have an x, so it's going to be replaced by 2x plus 1 over x minus 3, and then minus 3 over here. Then we try and simplify the numerator and then the denominator. So let's try and simplify each one of them. For the numerator, I'm going to multiply these two throughout. So remember, these two will only multiply the numerator, okay? And then you can write as 2 over 1 so that you know 1 is multiplying the denominator. So the denominator remains the same. So we're going to have 4x plus 2 divided by x minus 3 plus 1 over here, all over. Then for the denominator, we can find the LCM, which is x minus 3. Okay. The numerator is going to be still 2x plus 1, and then minus, remember this is over 1, right? So 1 goes into the LCM, x minus 3. You're going to have 3 times x minus 3. So let's simplify numerator, and then again, for the numerator too, our LCM is x minus 3. We're going to have 4x plus 2 plus 1 times x minus 3. That's still going to be x minus 3 because I'm multiplying by 1. All divided by x minus 3. For the numerator alone, let me use a different color for the denominator. So for the denominator, we have, I'm expanding the bracket here. So we have 2x plus 1 minus 3x plus 9 divided by x minus 3. Then the x minus 3 here will cancel the x minus 3 here. So all we have is the numerator and then the denominator. So let's simplify the numerator over here. 4x plus x here is going to be 5x, right? So we are going to have 5x at the numerator, and then positive 2 minus 3 is going to be negative 1 for the numerator alone. And then we come to the bottom, we have 2x minus 3x, that's going to be negative x. Then we have 1 plus 9, that gives us 10. So comparing this one to this expression, px plus k all over r plus sx, means that our p, which is the coefficient of x at the numerator, is equal to 5. And then q is a constant at the numerator, is equal to negative 1. Then r is a constant at the denominator, that's equal to 10. And s is a coefficient of x at the denominator, which is negative 1. And all these are integers as expected.
So we go to question number 5a, and it's about trigonometry. We prove the identity 1 over 1 over 1 minus sine theta plus 1 over 1 plus sine theta is equivalent to 2 over cos square theta. So all the time we can prove from left to right. From the left hand side to the right hand side. We can also prove from the right hand side to the left hand side, which is going to be a bit more difficult than going from left to right. So I'm going to go from left to right. The 1 plus 1 over 1 minus sine theta plus 1 over 1 plus sine theta. Straight away we find the LCM, which is 1 minus sine theta times 1 plus sine theta, which is basically difference of two squares. So that's going to be 1 minus sine square theta. So I have from the left hand side, right, 1 over 1 minus sine theta plus 1 over 1 plus sine theta. So that is equal to, our LCM is 1 minus sine theta, 1 plus sine theta. So everywhere here, we have this one divides this 1 plus sine theta. So 1 plus sine theta times 1 will give us 1 plus sine theta. Then 1 plus sine theta goes into the LCM, 1 minus sine theta. So that multiplies 1, and we have 1 minus sine theta. So we simplify the numerator and denominator, and then we have 1 plus 1 is 2. Sine theta minus sine theta is 0. So the numerator, we have only 2. Sine theta and sine theta out. And then at the denominator, we have 1 minus sine theta times 1 plus sine theta, which is basically difference of two squares. So that gives us 1 minus sine square theta, or 1 squared minus sine square theta. But we know that cos square theta plus sine square theta is equal to 1. That means that making cos square theta, we have cos square theta is equal to 1 minus sine squared theta. So that gets replaced over here. And then our identity now is 2 over, so 1 minus sine squared theta is the same as cos squared theta. And then that is what we are required to do.
Number 3b says that hence solve the equation. Now, the moment you see hence, what that means is that we should continue from our previous workings. Right? Sometimes you see hence or otherwise. If otherwise is added, it means that you can just start afresh and then solve this equation as if nothing has been done previously. And then hence only means that we have to continue from the previous section. Wherever we go to, we should continue from there.
So it means that there must be something related to this question and then the previous question, and that's where we're supposed to take everything from. So back to the first question, the part A, question 5A. We see that this expression at the left hand side is similar to the one in B at the left hand side, but the 3 on top, right? So we need to factor out the 3. And then we have the same expression in brackets as in part 5A. So we're going to factor out the 3 here. Now what we have in brackets is the same as what we find in A, 1 minus sine theta, and then plus 1 over 1 plus sine theta is equal to 12. Meanwhile, we set the one in brackets as given in part A is equal to this expression 2 over cos squared theta. We're going to replace the one in bracket by 2 over cos squared theta. So we have 3 times 2 over cos squared theta is equal to 12. Then manipulate this equation. 3 times 2 is 6. We do cross multiplication. So 6 is equal to 12 cos squared theta. We divide both sides by 6. Sorry, that by 12 rather, sorry. Here by 12. And then we have 1 over 2 here. So cos squared theta is equal to 1 over 2. We take square root of both sides. And then we have cos theta is equal to plus or minus 1 over root 2, which is the same as root 2 over 2. Right? We have two solutions. Cos theta is equal to root 2 over 2, or cos theta is equal to negative root 2 over 2. Now, this is a popular one. So theta is equal to, from this solution, theta is equal to 45 degrees. And yes, over here, calculator must be in degrees because the angle was given in terms of degrees, right? So cos theta, and cos is positive here, so cos theta is equal to positive root 2 on 2. It means that our answers are to be found in two quadrants. First positive in the first quadrant, sorry, in the fourth quadrant, and then in the first quadrant. So the answer we found over here, 45 degrees, is in the first quadrant. So we find the other solution in the fourth quadrant by subtracting the 45 degrees from 360 degrees. And that's going to give us 315 degrees for the first part. Now we go to the second part. Same thing. Theta, because theta is negative, it means that the answers are to be found in the two quadrants in which cos is negative, and that is the second quadrant and then the third quadrant. When you are punching this, what you have to do is to punch the positive part only. So you punch cos inverse of um, 2 root 2. So theta is equal to cos inverse of root 2 over 2, right? And omit the negative. Right? Then so you point this and your answer is 45 degrees. You draw the 45 degrees in the two quadrants in which cos is negative. So one is here 45 degrees and one is here 45 degrees. So we calculate the angle. So from here to here is 180 minus 45, and that is 135 degrees for the value of theta in the second quadrant. The other one is in the third quadrant, so that's going to be 180 degrees plus 45 degrees, and that gives us 225 degrees. So these are the solutions to this trigonometric equation.
And for question number 6, the equation of a circle is given by this. We are to state the center and radius of the circle. So the key thing is state. It means you don't need any calculation to find the solutions. So this is the equation of a circle in a completed square form. So the equation of a circle in a completed square form is like this. Plus y minus b all squared is equal to radius squared, where AB is a center and R is a radius. So over here, this equation is in this form, right, where A and B are zero. So basically we have minus 0 all squared
y minus 0 all squared equal to um 45 over 4 root of that all squared. It means that our center is basically 0, 0, and then our radius is just root of 45 over 4, which we can simplify. Root of 45 is 9 times 5, so that's going to be 3 root 5, and then root of 4 is 2, so that's our radius. We go to question number 6b. It says as the line x plus y equals 3 over 2 intersect the circle at the points A and B. Find the exact distance. So the circle's equation was given as x squared plus y squared. So yeah, write it here: x squared plus y squared equal to 45 over 4. What we're going to do is that we're going to make x or y the subjects in the line's equation and then substitute that into the circle's equation, and we're going to get a quadratic in x or y. Find those values of x and then find the corresponding values of y. So let's start by making y the subjects. So from the lines equation, y is equal to 3 over 2 or 1.5 minus x. So you put that in place of y over here. So wherever we see y, we replace it by 3 over 2 minus x. So the circle's equation becomes x squared plus 3 over 2 minus x because we found y all squared, right, equal to 45 over 4. Then we try and expand the brackets and simplify as well. We have over here x squared plus 3 over 2 squared is going to be 9 over 4. And then minus 2 times 3 over 2 x, and plus x squared is equal to 45 over 4. So I think we can still simplify. We have x squared here, another x squared here, so that makes 2x squared, alright? And then we have over here, the x term will become negative 3x, and we have plus 9 over 4 minus 45 over 4. So we're going to send the 45 over 4 all the way to this side, and it becomes 9 over 4 minus 45 over 4. So you take notice of the sign changes, right? Because it is negative over here, it becomes positive when you bring it to the left side. So 9 over 4 minus 45 over 4, that is going to be uh, negative 9. So it's going to be minus 9 equal to 0 after simplifying. We have a quadratic in this form and then we solve. Okay, so I think we have 2x, and then over here we also have x, and we have positive 3 and negative 3, so we have minus plus 3 and then minus 3 is equal to 0. So 2x plus 3 is equal to 0, or x minus 3 is equal to 0. On the left side we get x is equal to negative 3 over 2, or x is equal to, so these are the two values of x because the point we're going to get point A and point B, so we need to find get two values of x and find the corresponding y values. Meanwhile, we said y is equal to this, so y is equal to 3 over 2 minus x. We're going to do that substitution of x into y. So for this value of x, y will be equal to 3 over 2 minus another negative 3 over 2. That gives us 3 over 2 plus another 3 over 2, which is 6 over 2, and that gives us 3. And then for this value of x, that's when x equals to 3, y will be equal to 3 over 2, sorry, 3 over 2 minus 3, right? So we get 3 minus 6 is negative 3 over 2. So any of the points can be your A and another one your B. So my point A is negative 3 over 2 and then 3. And my point B, and this can be your point B anyways. So our point B is going to be 3 and then negative 3 over 2. And you find the distance between these 2 points. Distance formula, right? So distance between AB or line AB, its magnitude is square root of x1 minus x2 all squared plus x2 minus y2 minus y1 all squared. So difference between the x terms all squared. So I'm going to do 3 minus negative 3 over 2 all squared. So 3 minus or plus 3 over 2 all squared. And then plus 3 over here as well. 3 plus 3 over 2 all squared. Of course, first I started with this one. This was my x2. This is my x1. And later I started with this one for the y. It doesn't matter because you are squaring the numbers, right? So 2 minus 1. Okay, 2 minus, yeah, 1 is negative 1. But then when you square it becomes 1. The same as 1 minus 2 all squared. So it doesn't change anything, right? So we solve this and then our answer is going to be 9 over 2 square root of 2. So that's the magnitude of the line AB. Right, so question number 7. The equation of a curve C is such that y dx is equal to that y dx equal to this, and the curve passes through the point 47. Find y in terms of x. So the curve has been differentiated. So we need to find the integral of that curve. We're going to simplify the entire differential to make it look more simpler. We're going to start dy dx equal to x minus 3 all squared over the denominator can be written as x exponent half. So here we expand the numerator, we have x squared minus 6x and then plus 9 and everything divided by x exponent half. So I'm going to do it here by x exponent half, here by x half, here by x half, and then try and simplify. We're going to get, for the first part, we have um, exponents. We're just going to be adding the exponents, half plus 1. Sorry, subtract the exponent, so 2 minus half. Right? 2 minus half is going to be 3 over 2. And then the next one is going to be 6. This is exponent 1, so going to 1 minus half, which is also half. And then plus 9x negative half. So this is our dy dx, but then we are going to integrate this function finally. So y is equal to the integral of this with respect to x. Now what do we have from the integral? Y is equal to, we integrate this by adding 1 to the exponent and dividing by the new exponent. So we have x exponent 3 over 2 plus 1, which is 5 over 2. So here we have 5 over 2. The next one minus 6x half plus 1, which is 3 over 2. So we have 3 over 2 here. Then plus 9 x exponent negative half plus 1, which is half. So half here. And don't forget your constant of integration. Then we have y is equal to x exponent 5 over 2. Then we simplify the denominator. So it's going to be 2 here and then over 5. Then next we have 3 times 2, 3 times, no, 2 times 6 is 12 divided by 3. That's going to be 4. X exponent half plus 1 is 3 over 2. And then plus 2 times 9 is 18. X exponent half plus c. So that's our integral with respect to x. But then the question gives us an extra information saying that the curve passes through 4, 7. So we need to substitute these values. So x is 4 and y is 7 into the equation. So we have 7 is equal to 2 over 5. X is 4 exponent 5 over 2 minus 4. X is 4 exponent 3 over 2 plus 18. X is 4 half and then plus our c. Alright, so we try to solve this. To the left hand side we have 7 here, and then the right hand side everything else points in a calculator, and the answer is 16.8 and plus c, which means that c is equal to 7 minus 16.8, and our c is equal to negative 49 over 5. Now you can rewrite the entire equation, right? Y is equal to 2 over 5 x exponent 5 over 2 minus 4 x exponent 3 over 2 plus 18 x half and then plus c, where c is negative 49 over 5, and that is our solution. So question 7b says that the equation of a different curve d is also such that it has the same differential, but then this time around this curve passes through the point 4k. Describe in terms of k the transformation that maps c onto d. So we know c passes through the point 47, right? So I think 47. So you can do a little sketch and then understand this question. Let's say I have a curve over here. Let me draw my small curve over here. Let me use a quadratic curve, right? So, and this is 4, sorry, this is 4, and this is 7 for the first curve. So this is C. And then there is a curve D that also passes through the same 4. So let's say this is just a little bit up, which is D, and then a number here changes. So it means that the same 4 means that there is no change horizontally. So it has to be a vertical shift, right? So K, the 4 remains the same, but then 7 changes to K. So if K is more than, so let's say it is 410 now, right? It means that the new curve is just a shift of a vertical translation of the curve C 3 units up. Or in other words, it's a translation by the vector 0 and then 10 minus 7, which is 3. If the new curve lies below the old one, so if D lies below the C so that the y coordinate is, let's say, 4, then it's going to be, the translation vector is going to be no translation or no movement horizontally, but then 3 units down. So that's going to be 4 minus 7, right? So it's going to be 0, negative 3. So if the curve is above 4, 7, then it's going to be 10 minus 7. If it is below 7, it's going to be that number, which is 4 minus 7. So it means that the new curve over here, D is just a translation of C. So D the translation of curve C by the vector by the vector. So no change horizontally, but vertically it's going to be k minus 7, and that's it. Of course, you can also write a vector shift by k minus 7 units, and that is fine. So question number 8a, find the complete expansion of a minus 2x all exponent 4. So I think this has a formula in the, it's a binomial expansion and it has a formula in the formula page or formula book, which you can clearly see over here. So it's of this form, a plus b exponent n, and this expansion. So the first one is your a, the second one is your b. As a matter of fact, you can decide to interchange them and call this one your b, this one your a, and you still get the answer right. So we compare this to a plus b exponent n, and then we see that our a is the first term, so a in this expression is the, our b is a whole of negative 2x, and our n is the same as or is equal to 4, right? So we do substitution into the expansion. So we know the expansion is going to be a exponent from the formula over here, a exponent n, and then it goes on and on. So we have a exponent n, then plus n combination 1, all right, using the combination symbol, or all right, n and 1, so the same thing. Okay, so a n combination 1, where n is our 4, and then the next term is okay, then we have a, the first term, n minus 1, and b exponent 1, then plus next one is n combination 2, and then a n minus 2 b squared. So we go on, and the last term, because this one has exponent 4, n is 4, we're going to have a total of 5 terms for this expansion. So the last term is always going to be b exponent n. So we do our substitution and then we expand this. So it means that our expansion is going to be 3 exponent 4 plus 4 combination 1. And then remember a is still 3, so 3 exponent 4 minus 1. And then b is negative 2x. And the next term is going to be 4 combination 2. Our a is still 3, 4 minus 2. B is negative 2x. Make sure it's in brackets so that it doesn't confuse you. And then squared. The next one is 4 combination 3. And then b is 3 exponent 4 minus 3, which is 1. And then our b, sorry, a is 3 and our b is so negative 2x, so negative here, x exponent 3. Then we go to the very last term. We've had 4 terms, 1, 2, 3, 4. The very last term is plus our b, which is negative 2x, all exponents 4. Then we try and simplify each term. 3 exponent 4 is 8 to 1. And then 4 combination 1 is 4, because any number combination 1 is a number itself. And then this is 3 exponent 3. 4 minus 1 is 3. So 3 exponent 3 is 27. So 4 times 27. And over here we have times negative 2x. Then next term, 4 combination 2 is 6. And then this is 3. And 4 minus 2 is 2. So 3 squared, it becomes 9. And then over here, negative 2x squared. So negative 2 squared is 4. And s squared over here. Then next is 4 combination 3. And 4 combination 3 is 4.
And then over here, 3 exponents 1. That gives us 3. And we have negative 2x all exponent 3. That gives us negative 8x cubed. Then the last one is negative 2 exponent 4. And that is 16. So we have 16x exponent 4. We can further simplify them by multiplying the necessary terms. So we have 81 and then 4 times 27 times negative 2. We have negative 216x plus 4 times 9 times 6 is also 216x squared. And the next one is going to be negative. So 4 times 3, 12 times 8 is 96. We have 96 x cubed and lastly plus 16x4. It's fine if you want to write by starting with 16x4. Nothing really changed. So this is our expansion. So this is our expansion. So the B part says that we are to use the expansion to the binomial given graph to find the value of this binomial or this value. So we just compare what we expanded there to this. So we expand binomial 3 minus 2x exponent 4. By comparing, we see that we have 3 over here and here, have negative 2 over here. The only thing different is that x in our expansion from a has been replaced by root 2. All we are going to do is replace x by root 2 in our expansion and then we find the value. We're going to rewrite the whole expansion. And then wherever we find x, wherever we see x, we're going to replace that by root 2. So we have 81, we scroll up, 1 minus 216x is going to be minus 216 root 2. Then next is plus 216 x squared. That's going to be root 2 squared. Then the next term was 96 x cubed. So it's going to be root 2 cubed. Then the last one is 16 x4. That's going to be 2 4. We'll try and simplify these terms. 81 still remains 81. And here to 216 root 2. Nothing changes. Over here, 2 squared is the same as 2. Right? So it's going to be 216 times 2. So 4 and then 32. So 432. And minus root 2 cubed is the same is equal to 2 root 2. So we're going to have 96 times 2. And then root 2. 96 times 2 is going to be 192 root 2. Then lastly, root 2 exponent 4 is equal to 2 times 2. So that's 4. So 4 times 16 is 64. So we group like terms 81 plus 432 tens without any set plus 64. And next we have 216 with 2 and then minus 192 with 2. So 81 plus 432 plus 64 is 577. Then minus 216, negative 216 minus 192 or 216 plus 192 is 408 root 2. So this is our value. And you are not supposed to put decimal because the question says that we are to leave our answer in the form p plus q root 2. So our p is 577 and our q is negative 408. And that's our answer. And that's our answer. So question number 9, we have to solve the equation given over here. So this is an equation with fractional index. We need to write it or rewrite it in a simpler way, in a way that looks easier, and oftentimes you get a quadratic. So we need to write it in a nice way so that we're able to solve it and do some replacements.
So what we're going to do is that we see 1 over 3 here. It's a sign that we can try and work around the 2 over 3 and get a certain 1 over 3 out of that one as well. We're going to rewrite the equation again. I'm going to write it as x exponent 1 over 3 all squared. Yeah, so in indices, to raise a power to a power, you multiply the exponent. So we have 3 here, 1 over 3. The exponent 1 over 3 all squared. Then plus, remember, 8x all exponent 1 over 3 is the same as 8 exponent 1 over 3, and then x exponent 1 over 3, then equal to 24. And then remember, 8 exponent 1 over 3 is the same as the cube root of 8, which is 2. So we have first term is x 1 over 3 squared plus 2x 1 over 3. Let's send the 24 here equal to 0. And we have x exponent 1 over 3, which we can replace by a different variable. So we let's say m equals x exponent 1 over 3, and then we solve. So we have our equation to be m squared plus 2m minus 24 is equal to 0, and then we write this. So m out. So factors of 24, that give us 2 when added or subtracted, and then 24 when multiplied are 4 and 6. So because 2 is positive here, the bigger number becomes positive. So plus 6 minus 4. So it means m is equal to negative 6, or m is equal to 4. So meanwhile, our m is equal to x exponent 1 third. So it means that x exponent 1 third is equal to negative 6. And then we have x exponent 1 third is equal to 4. So we solve both sides. What we're going to do is that x 1 third. So you reciprocate the exponent. 1 over 3, each reciprocal is 3 over 1. So 3 over 1, which is the same as 3, equal to next. Do the same thing to the right hand side as we did to the left hand side. So 3 over here, the same thing. X 1 over 3, and then 3 over 1 is equal to 4, 3 over 1. So we have 1 over 3 times 3 is 1. So we have x here equal to negative 6 all exponent 3. That's supposed to be negative 2, 1, 6. And then over here, x is equal to 4 exponent 3, and that is 64. So the solutions to the equation given are 2 answers and 64. So the solutions are 2, 1, 6, and 64.
So we move to question number 10. The seventh term of an AP is 77. Then the sum of the first n terms of the progression is denoted by Sn. It is given that the sum of the first 11 terms is 880. We should find the 20th term of the progression. So since this is an AP, we're going to start with our formula. We know the nth term of an AP is un is equal to a plus the common difference n minus 1. And over here we have the seventh term, which is u7. So u7 is equal to a plus n is 7. So 7 minus 1 is 6. So we have 6z here. And then the question says u7 is equal to 77. So we have our a plus 6z is equal to 77. Let's name this as our first equation, or equation 1. Then next is the sum of the first 11 terms is 880. We also know that for an AP, Sn is given by n over 2 2a plus n minus 1 times d, right? And S11 has been given as 880. So n is equal to 11 and S11 is 880. So we have 880 here is equal to n is 11, so 11 over 2, 2a plus 11 minus 1 is 10, so we have 10d. Then we can get rid of the fraction by multiplying through by 2 over 11 and here by 2 over 11, right? So that's 2 over 11 times 880 will be 80 times 2, which is 160. And here 11 over 2 and 11 over 2 will cancel out, so we have 2a plus 10d. Then let's try reducing the coefficients by dividing through by 2, since each one of them is a multiple of 2. So we have over here, I'm writing the right hand side first. So I have a plus 5d is equal to 160 over 2 is 80. And let's name this as equation 2. So we have two equations to solve. We can use the elimination approach or any other method of solving simultaneous equations, right? So I'm going to do equation 2 minus equation 1. Equation 2 minus equation 1. It means the equation 2 values come first before equation 1's value. So first of all, a minus a gives us 0. Then the next one is 5d minus 6d. Then the right hand side is going to be 80 minus 77. Then it means that negative d is equal to 3. It also implies that d is equal to negative 3 if you make d the subject. So that's our value for d. Now we use the value of d to find the value of a from any of the equations. So let's use equation 2. From equation 2 here, we see that a is equal to 80 minus 5d. So we have 80 minus 5 times d. D is negative 3. So a is equal to 80 plus 15, and that gives us 95. Now that we have a and d, we can solve the question, because the question says we should find the 20th term, that's u20. So u20 is equal to a plus 19d, right? 19d. So our a is already 95, 19 as our, and then our d we had negative 3. So our u20 is 95 minus 19 times 3 is 57. So u20 is equal to 95 minus 57 is 38. So the 20th term is 38. Of course, the common difference is negative, means that the values will be reducing as the terms increase. So that's the answer to question 10. The question number 10b says that find the smallest number of terms such that the sum of the first n terms is less than 50. So this is a follow-up question from the first part. So we still keep the values of a and then d that we found. We found that a is equal to 95 and then d is equal to negative 3. And then you have to find the smallest value of n such that Sn will be less than 50. So first of all, Sn, you are going to capitalize the n. It's equal to n over 2, 2a plus n minus 1 times d. So for this term to be, and yes, we are going to replace a by 95 and then d by negative 3, but n will not be replaced by anything, as that's what we are looking for. So we're going to do that. N maintains its value as a big N, then 2 times 95, which is 190, and then negative 3 because this is negative n minus 1. This whole terms or this whole thing should be less than 50. Then we try and work around this. So let's see. We are going to multiply through by 2 to make sure that the fraction is cleared out. So we have over here n here, and then 90, sorry, 190, then minus 3n plus 3 after expanding the brackets over here. It's less than 50 times 200. Then we have 190 and minus 3n squared. Then next is plus 3n. I think we should have added the 190 and then a 3. So I'm going to do that later. 100. So we have over here negative 3n squared plus 190 n plus 3n will be 193n. Then less than 100. I'm going to send 100 here so that we minus 100 is less than 0. Then we try and solve this quadratic equation. So n is equal to, let's show a method of solving. Our b is 193, so negative b, negative 193 plus or minus b squared, so 193 squared minus 4 times a is negative 3 times c is negative 100, all divided by 2 times a, which is 2 times negative 3. So we try to find these values on a calculator, or you take your time, you do it, and then you have two values of n. N is equal to 0. To three significant figures, 0.522, or n is equal to 63.8. Yeah, so to three significant figures rather. But we need to find the values of n that satisfy this inequality. Of course, n must be an integer, right? It must be a natural number, as a matter of fact. So you can use a number line to find the solution to this, or try and use a quadratic curve. So let's try sketching a curve. Do a sketch for this one. You don't need to find any line of symmetry or turning point whatsoever. Just know this is a maximum curve because the coefficient of n squared is negative. So I'm going to do this. Okay. Then I will put the values, the two values here. The first one is 0.522 over here, and the other one is 63.8. Then we pick, we want to find all values of n that are less than 0. Less than 0 is below the line here. It's a different color. So less than 0 means below this line. And that is in between these two numbers. Right, so in between the two numbers here. Right, so that's one way. Another way we could have done this is to just draw a number line, put 0.522 here, and put 63.8 here, right? And then you pick a value either in between or outside these two numbers. So I pick a value at the left of 0.522, which is 0. Right? 0 is somewhere over here. So I pick 0, substitute into this quadratic. So you put 0 here, here goes 0, this is 0, and this will be negative 100. So after substituting 0, we get negative 100 is less than 0. And we ask ourselves, is this one true? Is it true that negative 100 is less than 0? And that is true. It means that the values here at the left of 0.522, and then the values at the right of 63.8 will satisfy this inequality, quadratic inequality, but values in between will not satisfy. So we have two intervals. One is values of n less than 0.522, values of n uh, greater than 63.8. But of course, we expect n to be an integer, sorry, a positive integer, so a natural number. So n should be, we discard the values here, all values below 0.522, as that is going to give us something zero, right, or less. So we pick values above this, so it means that for the sum of first n terms to be greater than 50, our n should be greater than 63.8. But then we have to find the smallest value of n, right? The smallest number of terms. So we round this to the nearest whole number. But since we are looking for the smallest number, we don't round it as 64 because we are looking for the smallest. So um, the smallest number, right, is going to be just cut off, or we chop off the decimal part, so that's the smallest value of n, so that the sum of the first n terms is greater than 50 is 63, and that is our answer. So that the sum of the first n terms. So question number 11a. The diagram shows the curve with equation given over here, and then uh, and a straight line as well. Okay. The straight line passes through the two stationary points of the curve. Right, so we can clearly see that here, a straight line here and a curve, but then the straight line means the curve at three different points, but then the reference made over here are the two stationary points of the curve over here and then down here. We are to show that the equation of the straight line is this y equals 8x minus 18. So what we're going to do is to find the two stationary points of the curve, and those 2 points are the points through which this line passes, right? So then we'll find the equation of the line using those two stationary points that we are going to find. So since it is stationary points, the first thing, that's our first point of call, is going to be differentiation. We're going to find the first derivative of the curve. So for the curve here, let me write that here, change the color of my pen. So y is equal to negative x cubed plus 9x squared minus 15x minus 3. So let's try and differentiate. Dy dx is equal to, we drop the exponents and then subtract 1 from the exponent. So negative 3x squared plus 18x minus 15 and then plus 0. We know as the stationary points, dy dx is equal to 0 as stationary. So we're going to equate what we found, the derivative, to 0. Negative 3x squared plus 18x minus 15 is equal to 0. Let's try and divide it by negative 3 to reduce the coefficient. So we have x squared minus 6x plus 5 is equal to 0. So x here equal to 0. So factors of 5 that give us, 5 is actually a prime number, so only 1 and 5. We have negative 5, negative 1. And from here we get x is equal to 1 or x equal to 5. So these are the x values at the stationary point. Over here, we don't need to determine whether 1 is maximum or minimum. After all, we can even find out that x is equal to 1 is a minimum, but we don't need that here, right? So we don't need a second derivative for any purpose. So we find the corresponding y value so that we're able to find the equation of the straight line. So we substitute the values of x we found into y. So for x equal to 1, y would be, let's find y. Y is equal to negative 1 cubed plus 9 times 1 squared minus 15 times 1 minus 3. So we have y is equal to negative 10. So negative 10 for this. So we have the point 1, negative 10. Then for x is equal to 5, we find the value of y. Y is equal to negative 5 cubed, which is negative 125, plus 9 times 5 squared, minus 15 times 5, minus 3, and we get y is equal to positive 22. So we have 5 and then 22. So we found the stationary point of the curve, and that's exactly the point where the line goes, right? So we have 2 points and we need to find the equation of a line. We just need to find the gradient. Our gradient is y2 minus, so let's name this one y2, x2, y1, x1. So our gradient is y2 minus y1 over x2 minus x1, or x1 minus, sorry, y1 minus y2 over x1 minus x2, right? So it's going to be 22 minus negative 10, so that gives 22 plus 10, and then 5 minus 1, we have 32 over 4, and that is 8. So the gradient of the curve is 8. Now the equation of the line is y minus y1. So let's use this one. Y1 is negative 10, so y plus 10 is equal to gradient 8, x minus x1, so x minus 1. Of course, instead of using 1 and negative 10, we could have also used 5 and 22 over here, and then we'll still get the equation. So I'm using this formula, y minus y1 equals m x minus x1. You can also use y is equal to mx plus c. Find your c and then find the value, find the equation of the curve. So over here, y is equal to, I'm setting the 10 there, so you have negative 10, and then we expand the bracket plus 8x minus 8. Y is equal to 8x. Negative 10 minus 8 is negative 18, and that is exactly what the question says. That we should show that the equation of a straight line is y is equal to 8x minus 18, and that's it. So the B part says that 11b says we should verify that the curve also meets the straight line when x equal to 3. So exactly what we said from the beginning. Remember, the line meets the curve at 2 different points. We found the 2 parts. One of them is 1, the other one is 5. So it means this part, the first point is 1, and then the second point is 5. Now we are to show that the next missing point over here is 3, and that's what we are supposed to do. So how do we show that? If indeed the curve meets the curve at the straight line meets the curve at x equal to 3, then the value of y at x equal to 3 is the same for the curve and then for the straight line. So what we are going to do is I'm going to substitute x equal to 3 into the straight line and find out what the value of y will be, and then do the same for the equation of the curve. If the two values are the same, then it means that the curve and then the straight line meet at x equal to 3. If they differ, it means that they do not meet. Over here, we have to verify. It means that they actually meet at x equal to 3, and then the values of y in both cases must be the same. If they're not the same, then there is something wrong. So for the straight line, y is 8x minus 18. So when x equal to 3, y is equal to 8 times 3, which is 24, minus 18, which is 6. And then we do the same thing for the curve. For the curve, we have y is equal to, the equation given was negative x cubed plus 9x squared minus 15x and then minus 3. So we put x equal to 3 in that, and we have negative 3 cubed, which is negative 27, and then plus 9 times 2 squared, sorry, 3 squared, right? That gives us 81 minus 15 times 3, 45, minus 3. So you do that and then you also get 6. So therefore, the line and then the curve meet at x equal to 3 due to the fact that the y values at x equal to 3 in both curves or in both equations give the same result, which is 6. Right? So yeah, this is what you need to verify to show that when we substitute the value of x into the two equations, we are going to get the same results, which we found to be 6 and 6. So the other point over there is 3 and 6. Sadly. So next, 11C says that the shaded region is bounded by the curve and a straight line. Find the area of the shaded region. So we check where the shaded region is over here, right? Between the line and then the curve. And then the curve is above the line at the shaded region. And the shaded region is between the x values x equal to 3 and x equal to 5. It means that if you are using integration, and if you are going to integrate the difference of the two functions, you have to integrate from 3 to 5 and not from 1 to 5. If you do from 1 to 5 and then the space here unshaded here has the same area as the shaded region, you're going to get the area to be 0, which shouldn't be the answer because the area here cannot be 0. Alright, so remember we are going to integrate, we're going to subtract the straight lines equation from the curves equation and then integrate that from 3 to 5, or we can integrate the curve from 3 to 5 and then integrate the line from 3 to 5 and then we find the difference between the two values. So I'm going to go the first one by doing the subtraction and integrating. So we're going to integrate from 3 to 5 the curves equation, which is negative x cubed plus 9x squared minus 15x minus 3. Then we subtract the lines equation. Make sure you keep it in a nice way so that the negative signs will not confuse you with respect to x. So let's do the expansion and then the like terms and our subtraction and addition. So we integrate from 3 to 5 of negative x cubed plus 9x squared minus 15x and then minus 3. We expand the brackets, we get a negative 8x plus 18 with respect to x. Now we have the integral from 3 to 5 of negative x cubed plus 9x squared. Now negative 15x minus 8x will be negative 23x, and then negative 3 plus 18 is going to be positive 15. Yes, and then we integrate this function. So let's go. You add 1 to the exponent and then divide by the new exponent. So we have the first term is going to be negative x exponent 4 divided by 4. Next is going to be plus 9x cubed, right? So I'm going to have 9x cubed divided by 3. So 9 divided by 3 is going to be 3. So I'm going to skip that step and write 3. Right, so the term is going to be 9x cubed. The new exponent is 3. So here and you have 3. So I'm only writing the x cubed. Then next is negative 23 x squared over 2. And the last term is 15x. Then we write our limit from 3 to 5 over here. Then we substitute the upper limit first before the lower limit, just in case you mistakenly substitute the lower limit first minus the upper limit, your answer is going to be negative, right? But then since you know we are trying to find area, and area cannot be negative, right? So you just make your answer positive just in case you interchange the substitution. So I'm going to substitute the value 5 and then do the same for 3. So let's go for 5. Going to have negative 5 exponent 4 divided by 4 plus 3 5 cubed minus 23 5 squared over 2 plus 15 times 5. That's the first part. Minus, we do the same thing for 3. It's going to be negative 3 exponent 4 divided by 4 plus 3 times 3 cubed minus 23 times 3 squared over 2 plus 15 times 3. So we do the first part. The first part after subtracting 5, and our answer is 6.25. Then the one in brackets over here will give us 2.25. So the area of the shaded region is the difference between this value, which is 4, and that is the area of the shaded region in the question. Jesus. So then, hold on.